So here in Talk the Thought Process, we're going to be working back and forth between names and symbols. So in chemistry, we'll refer to things with the symbols that come from the periodic table, and sometimes we'll say out loud or write out the names. And we need to understand the difference, how to translate from one to the other. But what's interesting about what we do in chemistry is that the way we name things actually tells us something about the type of compound we have, right? And so we've learned about ionic and covalent bonding, and we have to use different rules when we name things that are ionic or covalent. And so that's one way to kind of help to keep it straight, that the bonding is different when we have ionic compounds, when we have covalent. Ionic related to having cations and anions in there, and then the covalent bonding where we're sharing electrons between atoms. And so Robert Frost's a poet who said all the fun's in how you say a thing. And so that's one of the things that I like about chemistry, is that there are many ways to say the same thing. I'm sure it's very frustrating for students at times, but I kind of think that's a fun part of what we do in chemistry. So we need to learn the language. Okay, so here's the question. Name these compounds and tell if the bonding is ionic, covalent, or both. So we have a lot of them that we put here. And the first thing that I would suggest as you're trying to determine if something is ionic or covalent is, or both, is look for a metal, right? So if there's a metal in the formula, it's going to be ionic. That's just the way it is, right? Because metals give up electrons to form cations. And so in most of the compounds you're going to deal with here in general chemistry, if there's a metal in it, it's going to be ionic, right? And so this periodic table here, that comes from my textbook I'm using in the class. It's the Chemistry and Atoms Focused Approach. The yellow elements are metals. Yellow for metals, and again, a metal means it does not hold too tightly to its electrons. It gives up its electrons to form cations. The nonmetals here are shown in blue, and the nonmetals are nonmetals, right? So they don't tend to give up electrons. They tend to instead accept electrons, right? And so these can form anions over here. The metalloids are in between, so it's not clear what the metalloids might do. Kind of depends who they're hanging around with. Okay, so when I'm doing this problem and trying to name things, first thing I'm going to do is see if there's a metal. And if there is a metal, it's always going to be listed first, right? Because the more positive things are listed first in chemistry. So our first one is ClF3, right? So if we don't know where Cl is, we look around and we can find it here. It's a nonmetal, and it's bonded to fluorine, another nonmetal. Okay, so ClF3. Okay, they're two nonmetals. So we can answer the question that if they're two nonmetals, they are going to be covalent, right? So we can write that here, going to be covalent. And when we name covalent compounds, we have to indicate how many of the atoms there are, because we don't have any simple rules there where we add up the charges to determine how many different ions there are, because there are no ions. So this is going to be chlorine trifluoride, right? So that's a clue. If we have this di or tri or tetra in the name, that means it's covalent, right? How about this one? NCl3. So N is the first atom there. Is that a metal? Well, if we don't know, we can look, but it's not, right? It's over here in the blue part of the periodic table. And so again, we have N, nitrogen, Cl, chlorine, both being nonmetals. So these are going to be, again, covalent, just like they were up here. And we're going to have to tell how many of each element there are. So it's nitrogen trichloride. Okay, so that's my clue for you. Look for the metal. If there is a metal, it's going to be ionic. So So far we haven't seen any metals in these two. How about the next one, Ca? Now I know that to be calcium, and I know that to be in group 2, an alkaline earth metal. Group 2 means it's going to give up 2 electrons to form a calcium plus 2. All right, so when we see that metal in there, we know right away that it's ionic. All right, what's the counter ion? Well, we don't have just one atom that's a counter ion. We have this SO4. That's what's called a polyatomic ion. And so you need to make yourself familiar with those. This one's called sulfate. And so this compound then is called calcium sulfate. Okay, and so if you look up sulfate, you'll see it has the formula SO4 and it has a charge of -2. And we just determined that calcium is +2. Okay, so whenever we name something that is ionic, where we know the charges on the ions for sure, then we can just say calcium sulfate. We don't have to say how many of each, because we know as chemists that we have to balance the charge. And if we know that calcium is +2, sulfate is -2, then there has to be a 1-to-1 ratio. All right, so there's a couple more on this page before we go on. How about we look at the palladium, right? Palladium is a metal, and we can find it here. Palladium is in the middle of the periodic table. These are the transition metals, and the transition metals give up electrons, but we don't always know how many, right? There can be a number of different cations that they can form. And so when we have a compound, we have to, when we name it, we have to tell how many, right? And so what we see in this compound here is that it's ionic because we have palladium. We have the polyatomic ion, that's hydroxide, OH minus hydroxide. And because there's 4 of them and they're negatively charged, it has to be palladium +4. And so when we name this, we call it palladium 4 hydroxide. Right? And the difference is we didn't have to say the charge on calcium because we knew it was in group 2, right? But for palladium, it's in the transition metal block, and so we don't know what the charge is going to be. That's where we have to name it. So try some more of these. And again, if you see a metal, it's ionic. If you don't see a metal, it's covalent. If you have something like calcium sulfate, right, it's ionic, but at the same time we have the sulfate anion, and within the sulfate anion we have covalent bonds because these are both nonmetals. So that one is going to be both. So give that a try. And then over here, let's try to write the formula and tell if the bonds are ionic, covalent, or both. And here we're given the names, right? And the name can give us a hint, right? We're still looking to see if we have a metal, right? That's helpful. But the name also gives us a hint, right? So for example, this first one, boron triiodide. Now, boron is one of the metalloids, right? So we don't necessarily know with boron if it's going to give electrons, take electrons, share electrons. What is it going to do? It's kind of in the middle of there, right? But we have a clue from the name, right? The name that was given is boron triiodide, right? So that's going to be boron with 3 iodides. And because the name specifies the number of iodides, then this is covalent, right? If we knew it was boron 3, then we wouldn't have to say triiodide. But we don't know because it's a metalloid. It's right there in the middle, and we're going to call that one covalent. Okay, let's look at some other ones here. Again, we want to look for the metals. If there's any metals, and those ones are going to tell it's ionic. So we can actually go through here and answer some of these quickly if we know our metals, right? Ammonium and sulfite, those are not metals. They're not even on the periodic table. Phosphorus trichloride, okay, the fact that we have a tri here, again, tells us it's not a metal, right? Because we need the tri when we're naming things that are non-metals. That's phosphorus trichloride. Magnesium chloride is a metal, right? We had magnesium already, I think. Magnesium here in group 2. So that's a metal. So that's going to be ionic, because we know that magnesium is going to be +2. Calcium is right there by magnesium in the periodic table. Calcium is also going to be +2. Okay, so these two are ionic. The counter ion for our magnesium here is chloride. Chloride is in group 7. So it makes Cl-. So we know we have to have 2 of those to balance out the chlorides. Calcium here, though, has a counter ion phosphate. And phosphate might be one of those things we don't know, right? One of the polyatomic ions. PO4 with a -3. We might have to look that one up until we learn it, right? But calcium phosphate then is going to have to be calcium 3 calciums, phosphate 2, right? So that the charges will balance. 3 times 2 is 6, 3 times 2 is 6, right? So again, we don't say tricalcium diphosphate. We just say calcium phosphate because we use our chemistry to determine it's in the ratio of 3 to 2. Okay, how about this one down here? Iron 2 oxide, right? Iron is a transition metal. And even if we didn't look at the periodic table and know that, when they give us the Roman numeral in parentheses, what that's telling us is that that is a +2 cation, iron 2, right? It's also telling us that's a transition metal, because for the other cations, like calcium, we didn't have to designate that it's +2 because it's not a transition metal. It's in group 2, and it's always +2, where iron can be either iron 2, or as in this next example here, it can be iron 3. Oxide is always 2-, right? So iron 2 oxide is going to have this formula here, iron 2 oxide, so that the charges balance, and iron 3 oxide is going to have this formula here, Fe2O3, to make the charges balance. So we get a lot of clues from the names and the formulas as well. And so we want to be very careful about our naming and our symbols and remembering what they tell us. So again, just to go back to this one, this is ionic. This is ionic because we have cations and we have anions. The phosphate has PO4 group, right? Phosphorus bonded to oxygen, and phosphorus and oxygen are nonmetals, right? So we have covalent bonding in that one. So that's the key. Look for the metal. If there's a metal, it's ionic. Look for a polyatomic ion. If there's one of those in there, that part of it's covalent. If there's no metals at all, it's completely covalent, right? And make sure we understand the rules for how we have to name them. So there, we've done it. We've learned and we've practiced. And so every time we practice, we get better and better at naming our compounds.